Hello, everyone. Welcome to the live sessions of data structures in Python. Uh, we are going to talk about the data structures, specifically linked lists. And we will talk the general concepts of linked list as well. And also we will implement single lists in Python. So before we get started to the details of linked list, why linked lists? Why we would like to learn linked lists in Python? Not only Python, but linked list is very important topic for any programming languages. Because linked list is very common in technical interviews. Uh, Linked list question is short and simple for an interviewer to ask, but they have complex solutions that really show off your problem solving and coding skills. This means that they are very common in technical interviews, so it is important to be comfortable with using this data structure. So interviewer are asking, especially using linked list, uh, yeah, because it is a data structures, because of it is easy to ask questions, but it is very hard to implement linked lists. So linked list is very common in technical interviews, so that's why we need to learn linked lists to understand and implement the technicals in different programming languages. In interviews, use a linked list when you don't know the number of elements in your list before you start. When do you use the linked list? Because you don't know the number of elements in your list before you start, you use linked list. You have lists that need to grow. For example, accepting input from files, the internet, other streams, etc. You use linked list, and linked list is also useful when you need to implement a more sophisticated data structure like a heap, a stack, or queue. So linked lists are very useful and important for software engineering. In computer science, a list is a linear collection of data elements whose order is not given by their physical placement in memory. A linked list is a sequential access data structure used for storing ordered elements. So, linked list is a sequential access data structure used for storing ordered elements. Yeah, it just storing for sequence of elements that is called a linked list. They prioritize quick and easy data insertion and deletion over item lookup. So linked lists are prioritize quick insertion, deletion over item lookup. All linked lists are collections of node data structures that are connected by pointers. So linked lists are collection of nodes. The nodes are connected by pointers. That's where the link in the linked list comes from. So we are going to implement specifically in this lesson to implement uh, singly linked lists using Python. Linked list is a linear collection of data elements whose order is not given. That is, the order is not given by their physical placement in computer memory. So this is a linked list representation. So the first one represents node that is called a head node, and the pointer that points to the next head that contains the of the next node, and the next node also connected with the other next node until the end of the nodes. So they are connected by pointer. The pointer is the link that connects the each nodes, and it also contains the address of the next node. The last symbol represents the terminator, which means the end of the linked list. If that is null, there is no head at this stage, which means the head is, the node is ended here. That's called terminator. So this is the general representation of linked list. The basic concepts of linked list is record of a linked list is often called an element or node. Each record, as you can see here, for example, 1, 2, 3, they are values. They are values, and the dot symbol represents node. The head node. The first node represents refers the head node, and the last node refers tail node. That is the end of the linked list, and the head node is the starting, the first node in the linked list, and others are the nodes that are connected each other, that are point each other, and the first node is pointed to the second node by pointer. That is called a link that connected to the next node, and this pointer contains the address of the next node in memory, and so on. So each record of a linked list is often called element or node. The field of each node that contains the address of the next node is usually called next link or next pointer. That contains the address of the next node is next link pointer that point to the next node. The remaining fields are known as data, information, value, cargo, or payload fields. Like, for example, in this case, 1, 2, 3 are the data or information or value each node contains. The head of the list is the first node. As you can see here, the first node is the head of the linked list. And the tail of a list may refer either to the rest of the list after the head, or to the last node in the list. This is the tail. The tail refers that the last node in the linked list. So the terminator or null value. There is no node in this case. The linked is terminated here. All right. Types of linked lists. Basically, we are going to focus two types of linked lists. That's singly linked list and doubly linked lists. Singly linked lists are the most common linked lists. Yeah, most of the time we are using singly linked lists to implement data structure and algorithm. That's why it is most common linked list. Here, this actually represents a singly linked list. Each node contains the data we want to store, as well as a next pointer to the next node in the linked list. As you can see here, each node contains the data that going to store, and next pointer to point the next node, or that refers the link to the next point node in the linked list. Here, each node contains data. Each node actually contains two fields. The first field is data or information or values, and the other is pointer, the next pointer that points to the next node, or that contains the address of the next node. Next refers to the next node. So each node contains the data we wanna store, as well as a next pointer, as you can see in the figure, to the next node in the linked list. Singly linked list support traversal in only one direction. So this singly linked list is the most common linked list, and the most common interview questions in list is find the way to access earlier information in the list. This is the most common interview question. So traversing means visiting each node of the list once in order to perform some operation on that, which means accessing each node in the linked list. Traversing means singly linked list is supports traversing. Each node can be accessed uh, at once. It is one direction. As you can see, this represents a singly linked list because each node are in one direction. There is no reverse direction. That is called traversing. Traversing means just accessing each node at once. Just once you access the first node, the next pointer points to the next node, and you cannot access the first node again because it is one direction. That's called a singly linked list. That's called a traversal in linked list. The pointer is the memory location of a data structure, because I said the pointer is that point to the next point, which means that contains the memory addresses of the next node. A node, a data structure with two fields, as you can see here. This is a node which contains two fields. One is the data field, contains the information we want to store, and the other field is the next field, which is a pointer to the next node in the linked list. So this every node has two fields, one to store information, that is a data field, and the other is next field, which contains the pointer to point to the next node, or that contains the address of the next node in the linked list. All right. A linked list can be thought of a series of nodes, as you can see here. This represents a singly linked list with size of 4. First, as you can see here, the first is a head pointer that points to the first, that is called head node, and the first pointer is head pointer. The head pointer directly points to the first node, which means that contains the address of the first node in computer memory. And once the head pointer points to the first node, that is head node, the head node also contains the data field and the next field, and the next field that connects or point to the other next node, that is the pointer, and so on. It continues until it's terminated, until it reaches to the tail or the last node. The last node is pointed to the terminator. So every node should be stored in the computer memory, because of every node contains the pointer that point to. So, for example, the first node has a pointer, head pointer, which contains the address of the first node, and so on. And the last node also contains the address, point to the terminator, the end of the linked list. So this is a simple representation of singly linked list. So our target in this lesson is we are going to implement this figure in Python. So it is simple implementing in Java because Java supports libraries or modules, I think so. But Python doesn't support any libraries or third parties in implementing linked lists. So we are going to create a Python code to implement this singly linked list. A node for a singly linked list, a head is a pointer to the first node, as you can see here. That's called head pointer. In the linked list, all nodes are accessible from the head node. The other nodes, are accessible from the head node by visiting the chain of previous node. And the tail is the last element in the linked list. The next pointer of the tail element points to null to indicate the end of the list. So that is called a terminator. And size is the number of elements in the linked list. So in this case, you can count how many number of nodes we have in this figure. 1, 2, 3, 4. Don't count the head pointer and the null, because the head pointer doesn't contain a node and a data. Every node in linked list contains has two fields, the data field and the node field. I mean the next pointer field. So the head pointer doesn't contain those fields, so it is not counted as a node. So the terminator also the same. We don't count the terminator as the node. So in this case, we have 4 nodes. So common linked lists operations, you can see, you can implement those common methods or operations in Python. The find method that returns a pointer to node containing value in the field, or null if it isn't in the list, which means that node is not in the list, that returns null. This method can be used for membership checking as well. So the time complexity of finding the value is a big of n. N is the number of elements in the linked list. Find index using index returns a pointer to the index node from the head pointer, or null if the index is no longer than the length of the list. That is big of index. The time complexity is big of index. Adding beginning at the beginning of the linked list, you can add elements. That is, adds a new node with a data field containing value to the beginning of list, adding elements into the linked list. That because we add one element, so that is called big of one. Time complexity is big of one. And we can also add after the linked list, after any value, and so on. There are other methods we can implement. But in this session, I'm going to just implement how can we create a singly linked list using Python. Let's try to see the implementation of singly linked list. How to create a singly linked list? The first is start with a single node. Let's first create a class that is a singly linked list class node, because Python doesn't support any libraries to implement linked list. We just create our own class and implement all the methods by writing code. So this node class has a constructor. The constructor has, because this is a single node, every node, as I said earlier, every node contains data field and next field. Next field is contains the next pointer that points to the next node, or contains the address of the next node in the memory, which means pointer means that a memory location, or the location in memory. So this class has two fields. Every single node has two fields. That is a data and the next field. I just implementing this part. All right, let's go ahead. Then I'm going to create a single node by passing data, the data of the first node, or that is first node is called head node. Then that is the value is 3 in this case, accessing the data in a single node. So the next pointer is none in this case, because this is a single node. There is no other nodes that link to the head node. So in this case, it's going to return 3. Okay, indentation error. Okay, all right. My mistake is here. All right, it is just accessing a single node. I just created single node. This single node contains two fields, the data field and the next field. The data field contains the informations or the values, and the next field contains the address of the next node, that is next pointer that point to the next node. But in this case, I created a single node, and the next pointer is the value of the next pointer is none in this case, because there is no next node. I just created one node, and that is called a single node in singly linked list. And I implement this diagram. All right, let's go ahead. Now let's join nodes to get a linked list. Let's create other nodes. First, create a single node, that is head node. Always first create the head node, and then we can create other nodes that connect to the head node, because every nodes should be accessed from the head node. For this, we create linked list class with a single head pointer, So this single node is a head pointer to the next node. So in this case, I'm going to here I created a single node, but here I'm going to also create another single head pointer that point to the head node Just I'm going to implement this head pointer. All right. Okay, let's create a linked list class, another class. And this linked list class has head pointer, the head node. So it's going to point to the head node, this one. This doesn't contain any node because the head pointer has no any data field or next pointer field, just to point to the head node, because every node has address in memory. So then the head node should be stored in the computer memory, and it needs the head pointer, because pointer is the next pointer is that point to the node and contains the address of the next node. All right. Then create linked list objects with a single node. We just create this, and I just access the head by object of linked list, and I just assign the value to the node. In this case, I just pointing to the head node. This all right. Let's run and accessing that is, in this case we have one node, and this node contains the head pointer. The head pointer is implemented here, and the head node is this one. All right. Now let's add required methods to the linked list class. Now I'm going to implement this kind of figure. I have created the head pointer and head node. Now I'm going to create other nodes and implement just accessing or traversing method operation, as well as insertion method. All right. The head node is just the same, but in this case we can assign default value none, and the linked list class, which is in this case it creates the head pointer. Now I'm going to implement insertion method for inserting new elements into the linked list, because I have created a linked list. I have created the node head and head pointer as well, and I can now insert elements into linked list. Okay, you can add elements to either the beginning, middle, or end of the linked list. And in this session, I'm going to show you adding elements after, at the end of the list. Insert at end, store data, just store data traverse to the last node, just accessing each node and until it reaches to the terminal. Then change next of the last node to recently created node. Now let's create object new node that assign that node to the head node. Then if self.head is, which is true, which not null, the head has any data or it has not null, it assign the current or temporary node is the head node. Then it's going to evaluate the while loop, which means that is the pointer, the node, the current node points to that next. If there is any next pointer, node, assign the next node current node. Then the current dot next is new node assigned to the node here. All right. Otherwise, if this is false, the current that the head node is the current node. Just stopped here. How we can traverse or accessing each node, how we can print out the elements from linked list. And by calling this method, we can add any into linked list, and we can also access the elements or printing out the elements from linked list. Traverse, which means accessing each element of the linked list. Traverse means just it is a one direction, just accessing element once. You cannot access again that element. Once it is accessed, you can to the next element until it reaches to the terminator. How it works, we keep the current or temp to the next one and display its contents. When the current or temp is null, which means it reaches to the terminator, as you can see here in the graph, which reaches to the terminator or null value, it's going to stop here. All right. So first, let's assign the first head, the current or temporary value element, and then we can just use while loop. If the current is not null, it continues accessing the data, or because we're accessing the data, the element from every node. As I said earlier, every node has two fields, the data field and the next field. And now after printing this, it's going to iterate and assign the next node to the current, because the current is printed and it is a traversal, because singly linked list is a traversal, and it we cannot access the element once we accessed. Once we print it out, it just go forward, and the current node going to be the next node until it reaches to the terminator, until the current node becomes null. All right. Once we implemented this one, let's call linked list, and let's insert by calling the insert method. In this case, I'm going to insert 3 elements, which means linked list with 3. I can add one more. I can add. Let's print out this, and 3 is added. 4 is added and 5 is added. Now I can add one more by calling insert and 7. It adds to the end. This implementation of insertion is adding element at the end of the